probably getting a little sick of me, but oh well, bear with it, okay? So, on to the next system that we have in the animal organization. Bones, skeletal system, okay? So, yes, we're going to talk about these lovely things. So, the function of the skeletal system is pretty straightforward, support and protection, right? It supports our body to be upright. If we didn't have bones, remember I showed you that picture of good old Jabba the Hutt? We'd look like a big pile of skin. So we have bones for support, but they also protect our vital organs. Think about our rib cage and our skull, okay? Aren't they housing something pretty important for our bodies? Yeah, the brain, lungs, heart, all that good stuff. So obviously they're for protection. We have 206 of these suckers in the human body. Okay, there's a lot more in a baby, believe it or not, because I'm going to show you a picture coming up. When a baby's born, all of the skull bones have not fused together, so those are actually individual bones. So in a baby, there's a lot more bones, but in an adult, 206. Okay, split up into the axial skeleton and the appendicular skeleton. Okay, the axial skeleton consisting of the skull and the spinal cord, and the appendicular skeleton is everything that comes off of it, the appendages, the arms, the legs, and so forth. Okay. All right, so what are bones exactly? Remember, I've told you guys many times, I think, that a bone is actually an organ. Okay? A bone is comprised of different types of tissue. So it's living tissue and cells. A lot of times people don't really realize that bones are living, okay? Obviously, that's why we hurt when we break a bone, because there's still nerve endings that go in there, there's blood that runs through your bones, but it is living tissue, okay? So here's kind of a general picture of a long bone, okay? We have small flat bones and we have long bones. And long bones have the same kind of makeup throughout our bodies. That would be like our humerus in our arm, our femur in our leg, our tibia and fibula in the legs. Those are all long bones, as well as the arms, the bones right here, the ulna and the radius. Okay, you have what we call the shaft right here, or the diaphysis, and in here is called the medullary cavity, which bone marrow is produced. Okay, that's actually really important because if you ever hear about stem cells. Stem cells come from bone marrow. Stem cells are basically cells that have not differentiated or turned into something specific. So like you've got cells that turn into muscle cells and cells that turn into bone cells. Well, stem cells have not kind of made its way to something very specific. So that's why they're able to make organs out of stem cells, because they can tell them what to do. Well, anyways, those are produced in the bone marrow, in the marrow cavity. At the ends of the bones, you have the epiphysis, okay? This is where growth takes place. You also have the cartilage on the end of these bones called the articular cartilage. But the ends of the bones are pretty much what we call spongy bone. They're very porous, and they give the bone a little bit lighter weight, whereas this diaphysis is what we call compact bone, okay? So it's a little bit more dense, typically. Not that it's not necessarily stronger than the spongy bone, but still it is a little bit more dense, okay, so the compact bone. All right, and then how do bones grow? Well, so I told you guys from birth they start off as cartilage. So here's a skull of probably like maybe a 1-year-old. So basically by the time you're maybe 1.5, this is probably a little bit younger than that. Yeah, actually, sorry, I don't know what I'm thinking. This is probably about maybe a 2 or 3 month old, okay? Because actually by the time you're 1 or 2, this soft spot is pretty much gone away, because these bones have turned, we call it ossified, so it turns to bone, and they grow together, okay? So when you start off, especially in the womb, your bones as a baby are pretty much cartilage. They're very soft. That's why you don't hear of very many babies breaking their arms, because their bones are very soft. And still until about 2 years of age, when they start to really harden and ossify. Okay, there are specific cells that aid in bone growth. We call those osteoblasts. I remember that by osteoblasts build. So BB, osteoblasts build. Then you have different cells called osteoclasts that actually break down. So C, clasts, break down that bone. You're constantly building and breaking down your bone because, believe it or not, you need calcium in your blood for all different things, especially muscle contraction. So basically, if the calcium levels in your blood go low, then your osteoclasts go into, overtime and start breaking down bone to release calcium into your bloodstream. If you have enough calcium in your bloodstream, then basically those osteoblasts will take some calcium from the bloodstream and start to build up the bone, okay? So you have this constant breaking down and building up of bone, and ultimately you still keep the same shape, but you have that. Obviously you want to have that balance, that homeostasis of that, otherwise your bones can either become too thick or they can become too thin if your bones keep breaking down. The epiphysis and long bones, again, are for growth. You have a growth plate there that basically at around, say, age 18 in men, maybe even a little bit older, 18 to 20, those epiphyseal plates start to seal off and there's no more growth. In women, we typically stop growing around 18-ish, okay? But that's in the epiphysis. Gosh, I can't talk tonight. Okay, so bones, how do they hold together? Well, we have joints, okay? Joints are where two or more bones meet. Many different types of joints: ball and socket, hinge, gliding, pivot. So this is a tiny little picture, but you can kind of see here in the knee, this is a hinge as well as your elbow. Okay, so these two places are where you have the hinge joint, okay, just like a door opening, kind of just opens and closes, okay. In the shoulder and in the hip joint, you have a ball and socket, okay, so you have lots of range of motion. You can move around in circles and stuff like that. In the neck region, you have a pivot joint, okay, that's a pivot joint. And then here you have a gliding joint in your wrist, okay, so you kind of have this gliding motion, all right, but also you can go like that too, but it's more called a gliding joint. So those are really important because obviously that allows us to move within our skeleton. But something has to hold those joints together, right? We have ligaments and tendons. So ligaments are bands of tissue that hold bones together, okay? So there's a big difference between a ligament and a tendon. A ligament is going to hold that joint in place. So take, for instance, in your knee joint, that hinge, you have all these different ligaments, the ACL, the LCL, the MCL, okay? Those all hold the knee in place, still allow for movement, but if you didn't have those, what would hold those two, the femur and then those two bones, the tibia and the fibula, together? Nothing. It'd be kind of like free-floating. Tendons, on the other hand, connective tissue that attaches muscle to bone. So we have all these muscles and they have to attach to bone by something, and that's called a tendon. So a ligament, you can sprain a ligament, okay? You can tear a ligament even, and your tendon, you typically, you can sprain a tendon as well, or actually you have strains and sprains. We could get into that too, but ultimately, things that can happen with your tendons, you can have tendinitis, overuse of it, so inflammation of the tendons. But basically, those are very different things, even though we kind of lump them together. Broken bones, okay? Many of us have had broken bones before. Unfortunately, I seem to break my arm every summer. I guess that's what happens when you live on the edge, because I love to do crazy things. But anyways, lots of breaks. Hopefully you never have a break like that. Pretty gross, right? Oh, it kind of makes you want to cringe. So there's lots of different bone breaks. There's a green stick where it kind of snaps, a spiral fracture, okay, where it kind of spirals around the bone, a comminuted, which is basically a fragmented fracture. Transverse is the most common, where you just kind of break it through. A compound fracture, where it goes out of the skin, kind of the grossest, most graphic breaks, okay. You also can have a vertebral compression, where you have this compression on your on your spinal cord, and basically you have a lot of problems that come from that, okay? That's usually due to a fracture in the vertebrae. So when you have a broken bone, okay, say this is the break, you have all these osteoblasts. Remember, they build up the bone. They start to basically go around the site of the break and build, okay? And they build kind of almost what looks like a bubble of bone. And then the osteoclasts go in there and they kind of break down that bone on the sides and shave it off. Now the cool thing is if you give your bones time to heal like you're supposed to, then typically you will never break your bone in the same place, because it's actually more reinforced than the original bone, okay? So you won't really hear of anyone breaking their bone in the exact same spot if they allowed their bones proper healing time. Okay? If not, then obviously you could break it very easily because you did not allow that bone to fully heal. All right, so there's always disorders when we talk about any of these systems. So let's talk a little bit about the disorders. You have osteoporosis. This can happen in both men and women. Typically, it's more common in women because actually, as women get older, they obviously go through the lovely thing called menopause, where their female reproductive system stops producing basically those hormones like estrogen, and the lack of estrogen basically causes osteoporosis, or it makes us more prone to it. Osteoporosis is basically where your bone breaks down. You're lacking that structure in the bone due to lack of calcium, but not necessarily just because if maybe you can get osteoporosis even if you're still taking calcium supplements. But your bones become very brittle. So here's a normal bone, what it looks like in the spongy bone. Especially in that epiphysis. Remember, the ends of the bone is where the spongy bone is. But in osteoporosis, you have these, the bone becomes a lot more porous, and the strength is then compromised. So a lot of times you'll have these fractures within the hip. So this is the femur, and this is that ball and socket joint. You'll have a fracture right here because it's basically not very strong. So any kind of a fall can cause a hip fracture. And then typically those people have to go in and have a hip replacement. Okay, so kind of a bummer. So that can happen to a lot of people, but typically women. Let's move on to the muscular system now. Okay, the muscular system allows the body to move and ultimately live. And I say that because obviously our heart is a muscle, and it pumps blood around our bodies. And if we didn't have our heart, we would not be able to survive. Okay, but obviously our muscles too allow us all the movement we have. Another thing that the muscular system does is it generates heat. Anytime that you are moving, you're contracting your muscles, okay? Whether you are, all of the muscles that we can tell ourselves to move, those are called voluntary muscles. Those all are contracting as well as the involuntary. And anytime you have this contraction that we're going to talk about, you actually have this generation of heat, okay? So that actually is a huge function of the muscular system because obviously we need to maintain a proper temperature within our bodies. So another thing is, think about when you're really cold and you start to shiver. The reason why your body shivers is because your muscles are contracting, trying to heat and basically retain heat to your vital organs. So shivering is kind of a protective mechanism, okay? So the makeup of muscles. Makeup of muscles is basically protein strands that make up muscle fibers. So when you guys eat a big hamburger, you're eating the muscle of a cow, okay? So that's what we eat. The protein comes from that. It's just the muscle of a cow. So here's what a muscle fiber looks like. You can actually see this. This is obviously visible to the eye, but as you get smaller and smaller, it becomes microscopic. So you have a muscle fiber made up of all these muscle, or we call myofibrils, and then you can break that down even smaller to muscle filaments, okay? Now, in any kind of voluntary muscle, which are our skeletal muscles, you have these things called striations. Those are basically stripes that you would see, and if you were to see it under the microscope, you'd actually see that these muscle cells that are skeletal muscle, you could see stripes in it. Cardiac muscle also has those striations, okay? So I just wanted to tell you that the only muscle type that does not have it are the smooth muscle, and I believe I have a picture of that right here. So the three types are skeletal, which are your voluntary muscles, like your biceps. You can tell your biceps to, contract. You can tell your legs to contract and move, okay? Those are voluntary muscles, all the muscles that are kind of on the outer part of our bodies. Your smooth muscle is typically in your internal organs, okay? Your digestive system has a lot of smooth muscle. Your arteries and veins have smooth muscle. Obviously, involuntary, meaning we don't have to tell those muscles to contract. So in your stomach, as it's churning and using some of that smooth muscle, we don't have to say, okay, stomach, you might want to start churning my food now, okay? I mean, can you imagine if you had to tell your body to do those things? No, it happens all on its own. But smooth muscle has no striations, okay? No stripes. But skeletal and cardiac do. So cardiac muscle is only found one place. It's in your heart, okay? It is your heart muscle. And again, it is an involuntary muscle as well. We don't have to tell our heart muscle to beat, thank goodness. Hey, beat. Oh, beat. Can you beat again? Yeah, beat. Yeah, that kind of sucked. Okay. All right, now, how do our muscles actually work? So the action of muscles is actually a little bit different than what most people think, okay? They pull on bones they originate from. So they always have an origination where basically they start, we call it an origin and an insertion. So they originate at a bone, but then they insert at another bone, okay? The origin typically does not move, okay? The insertion is what causes the movement. So basically, they pull on bones that they originate from, and they work in pairs. We call them antagonistic muscles. They work together to perform opposite actions. The best example are your biceps and your triceps, okay? When you contract your bicep muscle, okay, you pull on this part of your arm, okay, and it causes a straight arm to flex, right? So you can feel that bicep muscle flexed, okay? Now, your bicep muscle never relaxes. You don't say, okay, time to relax. What happens when you straighten your arm is you're actually flexing your tricep muscle, okay? So when you straighten your arm, you're flexing this muscle, which causes this to lengthen. So there's no such thing as actual relaxation of your muscles. They just lengthen. So you can contract them, but in order to lengthen them, you have to contract some other muscle, okay? So it's interesting that muscles are always working in pairs in order to do the movements that we do, all right? Hopefully that makes sense. Now here's some details. Again, this is something that's a little bit more college level. You're going to get to the specifics of what happens in a muscle contraction, because in muscle contractions, again, you have a lot of different chemicals involved, different ions, different atoms. One in particular is calcium. I told you guys that the calcium levels in your blood have to be at a certain point, otherwise you're not going to have muscle contraction. If you have too much calcium in your blood, you can have something called tetany, where your muscles are constantly contracted and you can't relax them, which is kind of crazy. So anyways, the reason why we can contract our muscles are because of these two fibers, and I call them they are called actin and myosin, and I kind of like to think of them as like when my fingers are like this, okay, this is when the muscle is lengthened. All of a sudden you have contraction, and they move along each other like this, and the muscle shortens, okay, that's a contracted state. Okay, when an antagonistic muscle contracts, then you have the lengthening of that other muscle, so those muscle fibers. So these actin and myosin, okay, you have the thin filaments that are actin, and the thick filaments are called myosin. These are what cause the stripes or the striations in the muscles, the skeletal and the cardiac muscle, is all because of these, actin and myosin filaments. So in a relaxed state, you have, again, kind of like pulled apart where the actin kind of is further apart, where a contracted muscle, those actin filaments move along those myosin and they kind of close together, okay? So that's a little bit about it, but there are so many details that go around how a muscle contraction comes about, what needs to happen, all these influx of different chemicals and so forth. So it's very interesting that you can get really kind of detailed when you talk about the whole muscle contraction. So the use of muscles in exercise. How does one increase muscle mass? Well, just thought I'd tell you that basically you have strength training, okay? The more weight you're lifting, so the heavier your weights, you're typically going to build more strength and more bulk. So if you're not looking for that and you just want to kind of tone your muscles, then you're basically going to do a higher amount or higher reps with a lower weight. So like if you're looking for strength building and bulking, which a lot of guys like, okay, then those guys are going to do maybe 8 reps of a higher weight that really is difficult for them, and you might do 3 sets of 8, okay? But some people that want just to tone their bodies, a lot of girls like that, they might do 3 sets of 12 at a pretty light weight. You still want to be able to feel it, and you want it to be hard, but you're not like, oh my gosh, I need a spotter, so that's the difference between bulking up and toning up. But what happens when you bulk up is you're actually, when you're lifting weights, you're causing these micro tears in your muscles, okay? They're not bad, but that's what's happening. And then if you go and obviously, hopefully you're eating protein and you're kind of replenishing your body then repairs that muscle tissue and makes it stronger and also bigger, okay? So that's what happens when you strength train. All right, so can muscles contract with never getting tired? Well, yes and no. Certain muscles can. Obviously, our skeletal muscles get tired, okay? There's a point where they reach this, I can't do anymore. But your smooth muscle, and your cardiac muscle, they never really get tired. And when they do, you die. So, kind of interesting to think that some of your muscles will never get tired until the day you die. Kind of cool. All right, last video, and then we'll be done with this section.
Walking. A highly coordinated series of falls that we've taken for granted since we were toddlers. Requires no fewer than 200 skeletal muscles. Back muscles to keep you from falling forward. Abdominal muscles to keep you from falling back. It takes 40 or so muscles just to raise one leg and move it forward. Or simply making dinner plans and picking up groceries. The whole thing would be absolutely useless without an infrastructure. As our day pushes on, these skeletal muscles lift us through it, usually without our thinking about it. Without them, we couldn't run, or blink, smile, or speak for that matter.
Hello?
Just muttering a single word.
Hello? Hello?
Involves muscles in the face, lips, tongue, jaw, larynx. As many as 100 muscles.
Okay, so there's just a little bit on the muscular system. Hopefully that gives you guys a little bit of a background on the muscular and skeletal systems, but I know that you guys have heard those before, probably in your past, but there's a little bit more for you. Alrighty.